Very interesting. So, where did we get to last time? I think I was at the point where the debugger was running and we were able to launch a process and we were able to add breakpoints and see them being set in the memory view of the disassembly. I think the next thing to do logically would be to re-enable single step. Yeah, I think that's the next thing. So there's two things that are interesting. I think first I just want to check. No, what I'm going to do is I'm going to re-enable the simple version of continue, because that way I can check that the breakpoints are being hit correctly. And I already have this debug action continue here, so in Drake at some point there is an input control C for continue, right? And at the moment we've got all of this stuff disabled. Interesting message there came up from one of the chat servers. Just having a quick look at it. Some denial of service or something. Right, yeah, so when we hit C, if we are debugging and we are stopped, then we want to do something. We want to do the continue. I'm not sure if this debugging stuff makes sense now. Maybe we just call in to debug action and just do debug action continue or something. So let's see, I think I want to add breakpoint. I want to put it at the top, but I don't think I can unless I declare the prototypes. It'd be nice to have the kind of public API that's being called from Drake.cpp to be at the top. So here, add breakpoint. We've got this stuff that takes the action only if we're debugging, otherwise it queues it. With continue, we're going to want something similar, right? We don't want to do it if we're not debugging, because that doesn't make sense. I'm tempted to just stick that inside the debug action. So let's just create that and see what it's going to look like. Debug action continue. I think I've called it resume in other places. Excuse me. I kind of think that's all we need is the action, because the action's got the debuggy in it. going to keep the main debugging check in here. It feels like the logic should be around the key press rather than just calling resume, because otherwise it should be called something like resume if paused or something. I feel like this action shouldn't even be available, and this code needs to kind of know when it's not available. Now, this debuggy state equals stop thing might not be accurate. Maybe we don't require that. Ooh. But we do at least need to be debugging. And then we also need we kind of need to be stopped at a breakpoint or something for this to work. I'm just wondering whether it's worth being able to queue up or continue even if you're not actually in a stop state. So let's just do it. Resume. So this stuff here, let's just pull that out for a start. So we do need to do a check like this here to see that we're not in a state where we're not debugging. So if we're not debugging, that means we are debugging. Then, and also okay, that's fine. I think that's enough to queue up. Because that's kind of the same check as main debugging. They should be equivalent, I think. Then we want to find. Well, this is all the complicated logic, so I'm just going to F0 this out. As I said, I wanted to implement a simple version of continue first. So I don't think I need that either. So the simple version here is just to call debugger resume. Because that actually runs the ptrace that starts the process. We also need to check that we're in the stopped state, right? Because we can't do the resume unless we're stopped. So at this point here, we need to say, okay, are we stopped? And if we're not stopped, oops, then we need to queue up an action and do debug action type equals debug action continue. I'm going to call it resume here as well, just to be consistent. I'll just rename that in a minute. And then I don't think we need anything else. That's enough. We do need to check that we're not already doing something else. Probably. So this check here, we're only going to do this if we're not in the middle of doing something else. So if we're not doing something else and we are debugging, then if we're already stopped, resume. And if we are not stopped, then cue the resume. Seems fine. Okay, so I'm going to rename this continue here to resume. Then I think it's down the bottom of this file. We've actually got the continue here. We should rename that to resume. And the simple thing we want to do is just grab this and slap it down here. The other thing I could do to avoid all of this do it now stuff, or this if we're stopped then do it now, would be to make sure that the debug action process happens after input. So maybe I'll do that. So there's all the input, and that's processing the action. So we're going to move that below, then we can get rid of all of that conditional logic. And copying all of this related code as well, which I think is important to include nearby, because it's mostly going to get moved over to debug action, I think. So again, doing input, more input. There you go, that's the end of the input. Stick it in there. I'll stick a note up there to make sure it's clear. Needs to come after anything, any code that would enqueue a new debug action, so that we do not get a frame, we get 1 frame of delay. For example, the input handling should all be before this point. Oh my goodness, it's people saying things in chat that I wasn't noticing. How long? For like 7 minutes. I apologise. I was into it. Oh, we've got a link to something. What's this a link to? Is it? Whoop! Awesome. I don't mind. Hey, Miblo. Right. Things. I was doing things. Input handling, I should say that causes debug actions. Should all be behind. Ooh, what did I press? Wasn't what I meant to press, for sure. Okay, so I think now I can probably say don't bother with this stuff, just do this. And in here, where we've got resolve breakpoint if necessary, we can just say, or provided we're actually debugging, then write this breakpoint out. If we're not debugging, it will get written out as during process spawn, because that writes out all the breakpoints. So that's why this is kind of snuck inside this if debug action none thing. So does that compile? It should do, really. Everything should just compile. Redeclared. Redeclared? Different kind. Previous declaration of debug action type, debug action resume. Oh, that is a problem. I should rename these. Debug action type. We have a name clash. Next. Next. Oh, next. 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 All I can smell right now is barbecue sauce, because I just had some chicken with barbecue sauce. It's quite distracting. I've done that one. I've done that one. Keep up. There we go. Ooh. Is that everything? All the things? All the compilings? It is all the compilings. Let's run this. Okay. So, disassembly view, I'm going to launch the process. Didn't crash. Good start. Let's take the cursor down to this breakpoint. We see it. Can we set a breakpoint without frames delay? Because that's what moving that stuff around should have done. Yes, we can. That's better than all that. Better than all of that conditional logic. Now, the moment of truth. Can we hit C for continue? Oh, that does not look good. I think I know what I did wrong. Weird. If I open the... Ooh. Open the... Oh, it's broken. I was going to say, if I open the threads view, where does it think it is? I think I forgot to take it out of the continue state. So when we do this resume, we don't actually clear the state. So it's going to keep resuming, which I'm not sure why it came up so many times. Yeah, I think I know what I did wrong, but who's to say? I always think I know what I did wrong. Well, that's not true. Sometimes I haven't got the faintest idea. Okay, let's try again. Hit continue. It did something and then stopped. Okay, okay. Where do you think you are? You think you're in main, but you're not showing me that you're in main. Why is that? So it thinks it's at 400.819. Which it would be if it hit the breakpoint. So the fact that it's not showing the current really running instruction, which should be putting a red line over the top of where it thinks the instruction pointer is because we kind of commented out on the code that does that. Which is great. So let's fix that. Now, if I remember correctly, that stuff all happens in this commented out piece here. Let's have a quick look. So this piece of code I think we now have in our process, right? So here we've got state changed if we haven't got unknown. I think I like the way I wrote it there better. Not that it really matters that much. I think I must clear state change to false every frame or something. So you could rewrite this like this. State changed equals false. Right. If you could type, you would anyway. Then if debug action debuggy. How much do I use debuggy? Quite a lot. I'm just going to store that out, right? So here we can say debuggy star debuggy equals debug action. Okay. Now I can just do that, and then I can get rid of this. Let's say if update.state is not equal to debuggy state unknown, then stuff renders really weird. Then we can set our debuggy state equal to our update. Yeah, this just feels like clearer to me. This seems clearer than what this is saying here, but I like it better. So I'm going to do that. I might put a note up here. I mean, it's kind of an obvious comment, but it just kind of separates these out into chunks, right? Okay, then here, some of this can just go. So if the debuggy state stopped, stuff. Okay. So that piece of code definitely has been dealt with. So if the state is stopped, which is kind of what we've got here, and I already have this handle signal state, so that's that to do has already gone across. We have a queue of debug commands that are deferred until the next transition into stopped state. Okay. So if we changed into stopped state, right, because we're already ascertained we're in stopped state, so we must have just transitioned into stopped state, then we should check if we stopped at a breakpoint or not. So I think this is something that just kind of wonder if this is something that should only happen in this state. The problem with the none state is it can be overwritten by all sorts of actions. So I think if we handle hitting a breakpoint there, and there's a bunch of things we need to do in response to hitting a breakpoint, we shouldn't not do them because we had a right breakpoint queued up or something. Or we had some action queued up, so it feels like that should trump whatever's happening in this part. So I think here we want to deal with transitioning into stopped. For example, check if we have hit a breakpoint and need to do some follow-up actions. Because I know we do need to do follow-up actions when we hit a breakpoint, right? So now I just want, the actual bug we were observing was that the instruction pointer was not like getting stored away so that we were rendering it out properly. Right, I'm going to write this out and change this pane to a Drake pane so I can go and look at the way we render the breakpoints, which is in the render source. Let's look at any of the render functions: threads, watch, memory, assembly, disassembly, text pane, obviously. Okay, so in here somewhere we draw the instruction pointer. Draw executing line. These are so old I've used my other username. Okay, so where does it get this information from? Disassembly pane executing address. So somewhere along here we presumably set that. Okay, here. Which is just at the end of this, which I think is when we said it, we've transitioned, yes. So if we transition into stopped, there's a number of reasons that could have happened. We could have interrupted, we could have received a signal, or we could have hit a breakpoint. Now if we've hit a breakpoint, we should have a sig trap from our update message. So I think what I want to do is store the signal in here. So I can ask, but first let's just say have we transitioned. So that's if debuggy state changed, then okay, we have transitioned, and then we want to switch on update signal or something like that. And then we can say case, I haven't got a thing for this, signal type, sig trap. Maybe there's a different thing, I don't have to create my own signal trap, maybe there's another. I could probably just do sig trap like this. I have the right thing included. I don't know. Okay, so if we get a sig trap, then we know a breakpoint, probably. The other thing we could do is a bunch of the other ptrace special stops or debug stops. So this is actually really just we hit a debug stop, I should say. Whereas if we had some other signal, we might be some other thing going on. But we know we're in stopped, and we set like stopped thread, new thread or something if it's a sig trap for a new thread. So there are other things you can set up, like we're entering a system call and these sorts of things. I think you can pull that information out each time. So maybe this, I don't know, maybe this needs to be abstracted. Maybe this is too coupled with our update. Uncomment all the things. You mean all this stuff, this grey stuff on the left? Yeah, I should probably do that. Right, I'm gonna leave this like this, but I kind of want to think about whether this is kind of too low level. Maybe this should be like I'm checking this debug state, and then I'm checking this signal type. Maybe that should all just be one check. I don't know. Okay, so I'm going to put probably a breakpoint. Check this. I want to make this always be a breakpoint, so I know for certain what's going on. Right? Oh, did something there. I'm going to need to get a drink of water in a minute as well. Let me just see. I also want to keep track on how long I've been streaming, right? Half an hour. Okay, cool. So if we hit a breakpoint, the things that we need to do are I want to put this at the top, because this happens at the bottom. This happens no matter what. Update our idea, or update our instruction pointer, our executing address, I don't know, what do I call it? It's a bit at the bottom here. This seems like the wrong place to have this as well, really. We should cache it, because we've got to pull it out of the instruction pointer, and we kind of want to know what was the... Last time we transitioned to the stop, what instruction were we on? But I don't think sticking it in the assembly pane is the right place. It should probably be in the debuggy. So let's just change this to drape age. I don't want to move. I want to move that now. I don't really like it being there because I don't have access to the disassembly pane or main from this piece. So I want it to be in the right place, really. So debug E. In here, where's pane? I think a bunch of the stuff here that's in disassembly pane is going to end up moving out. No, actually, those things are probably good. Actually, should this be somewhere else? Look, wow, like I know myself better than I even know myself. If you know what I mean. Shut up. That made sense. Okay. You have to go deeper, all the way down into the darkness, until you find the variable. That's true. Very true. I feel emotion overcoming me. I feel like I need to mess my hair up and go lie down on the bed or something. I need to search for the missing semicolons in my life. So here, I've got the debugger already. That's just fine. We can do that. No problemo. Update the cache of currently executing instruction. Bonza. Oh, very interesting. We ought to force a redraw if we hit a state change. This is very true, but how do we do that from within the debug action? The debug action's got to communicate back to here to say we need to do a state change. Now I think the one way we can do that is we can just check debuggy and say if debuggy, which is in main debug action debuggy, if its state changed, then we should do a what? Yeah, we should do a main anim state equals anim state active. Right, so that's going to force a redraw. So that's good news, because that means that this bit here is kind of dealt with. I'm going to copy this piece of debug out here and just pop it in there. And we'll just say debuggy. Oh, I think I just did a capital I instead of a little I. Debug E that. Let's print out the instruction. I'm just going to mark this to do, because I think we have enough here to fix the bug now. Right. We transitioned into stopped. The other thing we could do is, there are other debug stops where we can read this. Like the new thread debug stop. I'm going to put a little to do here for that. Should we also update the cache in a stopped new thread? Question. That's a question, so it deserves a question mark. Oh. Compile Compilez-vous. Has no member signal. That's just true. Well, we're not even using this, so let's not be too worried about that. Right, while that's compiling, I'm just going to grab a drink. Fix. And oh yes, this is no longer correct. Do we have the debugger in this scenario? Wow, that's a long function. We've got main, so we can get it. Do we use it for fun? What? That was a bit of a jump. Okay. So, where was that error again? Here. Main, debug action, debug the executing address. Feels like that should be fine. Fixing that. Same thing here. Main, debug action, debug the executing address. Are these all in the same function? I don't think they are. Two in the assembly panes, and this one is in where? Text pane. Okay, so they're all completely different. So instead of getting them disassembly pane, we are going to get debug action. Debuggy. Okay. I hit my keyboard really hard sometimes. I'm used to a little bit more resistance than I have here. What's this? Decoded binary file. Compiling. Compiling done. Compiling complete. Running initiated. The red line appeared. Bug fixed. Apart from one minor problem. which is it's slightly the wrong instruction address because you haven't done all the fix up you have to do when you hit a breakpoint. So what's happened here is we've hit this breakpoint at 400818 and we've executed that int3 instruction to produce the sig trap to debugger. That means that our instruction pointer is now on the next instruction after that, which actually isn't or potentially isn't a valid instruction. Let's see. It is in this case, but we've skipped one instruction. We never ran this push RBP, which is going to cause us all sorts of problems if we just carry on from here. So when we hit a breakpoint, we need to rewind the instruction pointer 1 byte to move us back onto the int3, which is why continue is not as simple as you'd think. Because like if we need to continue again from here, if we've rewound onto the breakpoint, it's just going to breakpoint again straight away. It's going to do a sig trap drop to the debugger, which is why you need to clear the breakpoint, rewrite the original instruction back, step over that instruction using a single step, write the debug int3 back in so that if you're like in a loop or something, you'll make sure to stop at that breakpoint again, or if you're multi-threaded. And then you can do just a resume. So that's what makes continue slightly more complicated with software breakpoints anyway, where you're writing this stuff into the code. So we need to be in debug action. That's where all the debug action is. I'm just trying to remember where all this actually happens. So in resume inside the low-level debugging, we literally do the ptrace continue. Lots of noise from outside today. So I need to go find that extra logic that I put in here. I need another debug action over here, I think, which is going to point at our debug action resume. So this conditional stuff over here, just move that back into alignment. What we do, and this isn't going to go here, this is going to go down into the other piece of code, so let's copy it out here. Go down here and resume. Might have been slightly premature. There shouldn't be a note there. It's more of a to do. It'll become a note when I'm done. So that was our simple continue that we were doing. And we can do that for the first time we enter the process, because there's no actual breakpoint when we start the process up. What happens is we mark the process for debugging, and then we spawn it. Or we spawn it and then mark it. Either way, it gets marked in a special way so that when it hits a certain point in the process starting up, it automatically pauses it and just drops into a debug stop without having a software breakpoint written directly into the code. So continue will work in that case. In fact, even if there is an injected instruction, I don't think it's injected over the top of another instruction. I'm not quite sure how it drops into the debug wait, so it conceivably could have an int3 in there. But I think maybe the kernel just stops it. But importantly, you can just continue without having to mess around with it. So what did it do? Found our current instruction, checked to see if it's a breakpoint on that instruction. If there is a breakpoint, and that breakpoint has been written, we've overwritten the instruction that's there. That's what happens when we resolve a breakpoint. Is we write whatever was in that instruction into this saved word, and then we can just deresolve it by putting that saved word back where it was. And then we need to, this is where we have this queue of things where you'd single step, and then you have to push a debugger command that says next time you want to set the breakpoint back to being set, and then we want to resume if we're not already on a breakpoint. Because you could conceivably single step from one breakpoint straight onto another breakpoint. And if that was the case, you wouldn't want to actually do the resume, you'd want to stop. So those two cases are covered here. The problem with this is that if something else happens in the intervening time, there's just no real way to react to it. So this is kind of limited, which is why we're going for this this other case here. So in resume, I want to have all the logic to do these things as substates. And we can do that, but also do other things that, like, it's no longer a dumb queue where it doesn't understand what each slot in the queue does. It's now a state machine that understands exactly where in the state machine it is whenever it's doing a particular action. You can go off to do some other stuff and continue on in the state machine without worrying. Like, I think importantly, it can cancel what it's doing in the state machine without having to worry about, oh, do I have things left on the queue, and that sort of thing. Okay, so this, with the current instruction, I feel like that might already have happened up here. So I don't know that we need to do that again. Is that true? That should be true, right? We should always have an idea of what our executing address is if we are in the stopped state. And since we can only resume if we're in the stopped state, this should already have run. I think that's true. It feels like something that should always be true. So the executing address should always have an up-to-date value whenever we are in resume. The only thing we haven't done here is we haven't fixed the hitting the breakpoint stuff. So let's swap back to that first, because that's this fix-up bit which is in here. Okay, so we've changed into here. I'm going to ignore this little bit at the top here just for a second and say hit. Next. We just stopped at a breakpoint, then fix up so we can correctly resume execution. So I'm just going to copy in how we were doing before, and we can think about whether or not we need to add that extra signal information piece. And that's basically this bit here. And we need to do this before we work out what the instruction pointer says, because we're going to mess with the instruction pointer to do this. Oops. Didn't do that. Okay, so we'll get the breakpoint by calling debug action find breakpoint. What does fix up instruction do? I think it just does. It just writes to no. Okay, that's what. picks up instruction pointer, writes instruction pointer. Okay, so I don't know. That's kind of confusing. I mean, it's a nice name, but it doesn't really do anything. I think I just want to say what we've got here is a U64 executing address or instruction pointer. Instruction. I'm going to call it IP. Shorter. Let's take the IP, stick it into this variable here. Right. And then we're going to say IP -1. So if there's a breakpoint at the instruction before our current instruction, and that breakpoint has been written out, then make sure our breakpoint is enabled, because it shouldn't be, if it's not enabled, it shouldn't be written out. Then what's this? Take the instruction pointer. We've got that, so I don't think we need all that. That's a lot easier to read. Yeah, this should be true because, like, this is just a simple sanity check. Okay, so what's this do? Read word from address, breakpoint instruction address. Why do I keep reading the instruction pointer so many times? It just doesn't make any sense. What's this? Read word from address, breakpoint instruction address. I think this is just checking to see that we've actually got an int3 here, which is 0xcc. Don't assert it though, for some reason. That seems fine. We take that and we take our debug action. In fact, I think we have debuggy here, don't we? Do we have the debuggy? We do have the debuggy. I like the way that sounds. Debuggy. Okay. So I'm just cleaning up this code a little bit as we're working through it. So deresolve breakpoint is now something which is part of debug action. Right? We deresolve the breakpoint. Debug action, not main. So did I get everything out of this? Process ID. Oh, we're using the debugger, here we are. So here we can get rid of that stuff as well, because we've already saved that away. Then that, then... Okay. So this is just debugging for me to check that everything's working correctly. And now we want to set the IP to... Okay, that's one way of doing it. So we've already asserted that the IP address of... IP address? What am I talking about? The instruction address of the breakpoint is is at the instruction pointer -1. So we could do either here. We could say set the instruction pointer to the breakpoint instruction, or we could set it to the instruction pointer -1. They're both the same. And so I've chosen to do it this way, which is fine. I don't like this fix up instruction pointer for breakpoint. That just sounds like it's doing something different than write instruction pointer. So I think I prefer just saying write instruction pointer there, because it's like literally the same thing. And then we can get rid of this kind of useless function. What's this? This is asserting that our instruction pointer, which has now been updated, is equal to the breakpoint address. I don't know why I have that commented out. I mean, this is fine, right? I do think I want to run this command again, essentially. So we've written the instruction pointer. Can we read it back? I think we can. I think these write instruction pointer things happen immediately. So I think we can just like say we can read that out again. But maybe that's not true. Let's try it. So now we should have updated those to be the same after fix up. Hang on a minute. Did I delete something I didn't mean to delete? Oh, we've got deresolve breakpoint here. I'm just going to quickly back up a bit to make sure I didn't delete anything important. No, I don't think so. Okay, it's all fine. So this thing, I don't think this is being used. I'm just going to quickly check that. What's it called? Debugger fix up instruction at breakpoint. Maybe it's being used in deresolve. Let me just see. Okay, it is being used here. That's fine. That's fine. Okay, how are we doing for time? Over an hour. Right, let's finish this up then. Okay, so that's a search should work. We're saying what's the instruction of this address? That's all fine. That's the same thing we did up there, but now we've resolved the breakpoint. It might be different. Well, now we've de-resolved the breakpoint. So that was from before the fix up. This after fix up, and here is the instruction pointer again after fix up. So if we have gone through that stuff, then we already have the IP address. So I keep saying IP address. Instruction pointer address. I guess that kind of makes sense. So I think this can just be IP, really. Because we read it up here, so we just have it. And if we changed it, we kind of overwrite it here, so it's still correct, even after we fix it up. So I think that saves us quite a few calls to ptrace. I don't know whether that's going to have a significant performance impact. I doubt it's going to cost many cycles, really. Hey, purposely drifting. Good to see you. Yeah, things are moving along. I'm mainly refactoring at the moment, so this stuff is... This was working before, and hopefully it will be working again soon. But it's now, I think, in a better place. Just going to be taking a quick break. Apologies for that. Just my wife coming back. Oh, it's good to see you could catch it. I did do this one a little bit earlier, like a few hours earlier than normal. So that probably helped. I think this is pretty much ready to go. Okay. Do I have the right type here? What does this return? Read instruction pointer. Unsigned long long. And what do we have in executing address? U64. Pretty sure U64 is fine. Mm-hmm. So all these complaints are that I'm using a long long here. Okay, this can go. Didn't need that. Just missed one of these on my way through. Got a call to this. Don't need any of that. Just need the debuggy, so we've already saved that away. Oh, this is the other bit of code. I haven't really gone through this. It's not actually correct. This push debugger command stuff doesn't exist anymore. I already deleted it. So anything from the earlier code left? Here we've got a fine breakpoint. Okay, so that looks like the other. This reaction code now is compiling, which is good. So when you hit breakpoint, it's going to fix it up. That all seems fine. Even if we don't do this resume stuff, I think I'm going to comment this out. I want to test this. Ooh. I think what I might do is I'll leave this commented out here, and that'll be the first thing I do next time. Next stream, convert this code to the new state machine approach. And what I'll do is I'll see whether we fixed the problem where the instruction pointer is at the wrong place. I think I need to restart this here. I do also need to commit my code again at some point because I haven't committed this code, which makes me a little bit nervous. Okay, let's open the assembly pane. Let's start debugging the process. Let's have a look at this breakpoint here in memory view. Okay, now when I hit continue, I'm expecting what we were seeing before was that 400819 will get into the red line saying that this was the currently executing instruction. What I'm hoping is now it's going to lie on top of 400818, and also that instruction that's currently in int3 will change back to the push RBP. So here I'm just tabbing between looking at the memory in the debuggy process and looking at my image of the executables code. So there we go. Hit continue. Seems to have fixed it up correctly. Hopefully we had a log message up here. Let's see. So we got the stop state to say that we hit the, well, which happened because we hit the breakpoint. We must have detected it was a breakpoint because we started logging information about fixing it up. We can see that this instruction has a CC, which is the actual int3, because That's interrupt 3. Interrupt 3 is a 1 byte instruction of CC. The rest of this is because we're little endian here, it's probably the instruction before? I don't know. I don't know which word exactly we're reading here, but it's either instruction after or it's instruction before. That was the IP address that it was before we fixed it up, which was the one we saw it on before. We backed up the IP address to the location of the breakpoint, which was 1 byte before. It's always going to be 1 byte before because the CC is only 1 byte long. And that leaves us with this instruction. Now the CC has changed to a 5.5, which is presumably what was there before. In fact, we know it is because we can switch between memory view and normal view, and you see that the instructions are the same. Oh, I've lost my place. And the instruction pointer is now this. And this is just logging that we'd set that in to be the instruction pointer we're drawing. So it's all working correctly, as it was before I started messing with things. So we're kind of back to where we were on that front. So I'm going to finish there. I think I will do is I'm going to take a look at this, these changes I've made and start committing them. The first thing I'm going to do, I think, is I'm going to add that multi-threaded.c in. I think I'll add it in as a test fixture. So I have the test directory here, some fixtures in it, and I just call it simple multi-threaded. Let's see. Let's quickly update the compilation. Undefined reference to pthread create. That's kind of annoying. There we go. So that's compiled it in 32-bit and 64-bit mode. So when I actually run these tests, I don't have a test for multi-threaded at the moment, but I have these little C programs for checking that the debugging code works. So you can see here, it's like this one just spawns a process, stops it, and then runs a continue on it, all using the low-level API. So I don't think I've shown this at all. Maybe you can see here it's just using this low-level debugger API, spawning a process, waiting for it to stop, and then doing, I think, did it do a resume? It does a resume, look. And just making sure that I can test it on 32-bit and 64-bit, which is good. So now I should have that status. Simple multi-threaded. So I did that a while ago off stream, but it needs to be in the code somewhere. I've now got this debug action. Where is debug action? Okay, so this is in the current working directory, that's fine. Let's do a quick diff to see what else I changed. I'm in the middle of a refactor, so it looks like I've just commented a bunch of stuff out. tempting to create a new branch here just for this refactor or something. But I'm not. I'm just going to put like a work in progress mark on it. So what have we got here? Commented some stuff out in here. A whole load of stuff. I have no idea what... Oh, I know what that is. That was me commenting out the tests. So I had some inline tests for the DWARF expression evaluator. So I think I just put it in as a separate commit. So I'll do a git add binary file. Oh, yeah. Commit. Comment out DWARF evaluator. Tests. Testes. Yeah, they're just spamming a lot of testing, doing testing this, testing that out into the log output. So let's go with that. Again, that was a few streams ago. I think I did that. Possibly I didn't do it on stream. I can't actually remember. So then we've got this stuff, which is multi-threaded support. Right, this was me adding the ability to properly exit out of the multi-threaded process when the debugger exits. And this one was to, when you start the process, make sure that you're listening for new threads being created and attaching to them. So those are both multi-threaded support. This was something that I don't think we need anymore. I deleted it this stream. What else have we got in here? Debugger update now returns a struct instead of just a status code. And I've put in some information about understanding new thread information. So this is multi-threaded support as well. It's me setting the state to running of the debugged process when you start spawning the process. So it doesn't say that the state is unknown. Well, I think actually it was not debugging was the state that I added. I'm adding in debug action. I've moved a bunch of stuff to debug action, so that's a refactor of all the breakpoint code out into the debug action layer. Continued refactoring. So it's mainly multi-thread support and refactoring we've got so far. I think I'm just going to kind of commit all this together under that. This is me actually changing which file I'm debugging. I'm not accepting arguments in the command line. It's just launching this straight into the multi-threaded program. More refactoring. This is me commenting stuff out again for the refactor, which is in kind of work in progress. I don't think there's anything else in here. Refactor, what's all that stuff? Yeah, it's me commenting out all of that. Multi-threaded support by adding new states that you can be in for a new thread. Debuggy update result, that's the refactor. Changing debuggy. I'm not sure why it thinks they're all added. Alright, I just got confused because I've added something in between them. And then I've got this stuff here, which I think I'm just going to throw away. This is kind of multi-threaded. Me sketching out what the multi-threaded debuggy thing might look like. Need a new arena for the debug action layer. Need to give it some memory. And this changes multi-thread support as well. This is making sure that when we ask for has the debugged process actually had some event happen, we're also going to check all of its children threads. Okay, so I think I'm happy with just checking that all in under the same thing. So I'm going to add debug action. Then I'm going to go git commit -am and say work in progress whip multi-threaded support and refactor to debug action layer. I thought I set an alias for this. Okay, so that's all good. Just quickly check I didn't check in anything I didn't mean to. I did! Curses! I checked in the Drake debugger.c. What did I make in there? Drake debugger.c. Oh right, that's fine. So Drake debugger.c was my attempt to extract out the debugger API. I must have made that change in the actual debugger as well, because that's just like a copy of the debugging part of the debugger. So I'm just going to check that, because that'll be in debug.cpp, where we've got wait pid, I think. So this also does that, that's fine. So as long as they both do, I'm happy. There we go, all good. Just going to get rid of some of these extra files. Clean up 1Q. Can leave Gimli because that's actually my dwarf thing. And leave multi-threaded because I've currently got that set to be executed, even though I've got a copy of it I've checked in. Okay, I think I'm done. Thanks very much for coming and watching me program some more of my debugger. I'm not sure if I'll be streaming tomorrow, but I might stream again on Thursday. Things are trucking along nicely, and that's always very motivating. So it's nice to stop halfway through something so you know exactly what you need to do the next time you start up. So it's good to have this next stream thing that I know exactly where I'm going. Yeah, I'll catch you all later on in the week. Have fun. Cheers.